Hi, I'm Mr. P from Papapodcasts. I got a request today from Tim regarding a question that his daughter had with one of her math problems. So what we're going to be looking at here is the question. 3 to the power of 2 over 2 to the power of negative 2 multiplied by a quarter, 1 over 4 to the power of negative 3 divided by 3 to the power of negative 3 times 3 to the power of negative 5. One of the first rules that I'm going to talk about before I actually go into this question is the following. Anytime you have a negative exponent, so let's look at an example like 2 to the power of negative 3. One thing to do with these type of questions is, in order to get rid of this negative 3 exponent, put it underneath the number 1. So you have 1 over 2 to the power of 3 is another way of writing 2 to the power of negative 3. Now, let's go into solving the following problem. Now, those who are watching and probably thinking this is quite a difficult question, what we're going to do is we're going to break it up into 3 parts. Okay, this first part here, the second part, and finally this third part. Now, whenever we have a fraction as such, one thing I like to treat it as, what is the function that that fraction implies. So what it implies is 3 to the power of 2 divided by 2 to the power of negative 2. That's what this first part of the question deals with. So what I'm going to do is I'm going to now use the rule I said about the negative exponent, and I'm going to have 3 to the power of 2 divided by, we're going to convert 2 to the power of negative 2 to 1 over 2 to the power of 2. So the other rule now, when we're dividing by a fraction, we always multiply by the reciprocal. So what we're going to do is we're going to switch these two, we're going to reciprocate these two fractions, or the numerator and denominator in this fraction, and we're going to change this division into multiplication. So what we're going to have here is 3 to the power of 2 times 2 to the power of 2 over 1. But we're not going to need that over 1 because anything over 1 remains the same. So let's remove that. So that will represent this first part. Let's look at the second part now. I'm going to try to use a different pen. And this next part is going to get a little difficult, a little tricky, but still we're going to treat it the same way. So we're going to take this 1 over 4, okay, and it's to the power of negative 3. This line to separate the fraction, we're going to treat it as division. So divided by 3 to the power of negative 3. Now, as we said, anytime we have to the negative exponent, we're going to treat this as 1 over. Now, same thing goes with this example here. So what we're going to do is, what this becomes is 1 over 4 to the power of 3. Now, it might seem a little bit tricky. In a second, and I'm going to show you exactly what it's going to ultimately mean. Divided by 3 over 3, which becomes divided by 1 over 3 to the power of 3. Now, next step, what I'm actually going to do is remove the division. So to remove the division, we're going to find the reciprocal of 1 over 3 over 3. And that will give me times 3 to the power of 3. Now, whenever I have a question as such, okay, whenever I have 1 over another fraction, what this means is we're going to take the reciprocal of this. This is going to become now, it becomes okay, let me just explain this here. So 1 over 4 to the power of 3 is just like writing 1 divided by 1 over 4. So instead of writing divided by 1 over 4, we're going to write 1 times the reciprocal, 4 over 1 to the power of 3. So when we expand this, we're going to get 1 times, and this becomes 64. So in other words, this here is going to become, 64. Now, to simplify powers, you always want to have the same base. This here from our first part has the same base as this one. So that we're good. This power now does not have the same base. But what we're going to do is we're going to convert 64 into a power that is going to have one of these two roots that are common. And we cannot get 64 by using 3 as our main base, but we can get 64 by making 2 our main base. 2 to the power of 6 is going to give me 64. So instead of 64 times 3 to the power of 3 to give me this middle part, I have 2 to the power of 6 times 3 to the power of 3. So now I have 3 as my base, 3 as my base. 2 as my base, 2 as my base. And now I'm just left with my last part. So let me just get rid of this here. And we are going to answer this last part. Try to find a color that we can use. So, as we said, 3 to the power of any negative, or anything to the power of a negative, we turn it into 1 over 3 to the power of 5. So in other words, what we have here, okay, I'm going to remove all this middle stuff that we've done, all the work that we've done here. I'm going to keep what we found here at the bottom, and I'm going to combine them all. So what I have is from this part 1, I got 3 to the power of 2 times 2 to the power of 2. That's from the first part here. Then times the second part, I got what we have here, 2 to the power of 6, don't forget the times 3 to the power of 3, times this 1 over 3 to the power of 5. So what happens is, these are all now my numerators. I only have one denominator. So what I'm going to do is, let's get rid of this times 1, and we're just going to put it down underneath here. 3 to the power of 5. So what we have here, okay, times 1, so all this times 1 is not going to matter. The numerator is 3 over 5. So we're going to remove this, right? And that's what we got from here. This is just a all this is a combination from what we've worked on. So let's remove all that. And now what we're using is we're going to use the rules for the simplifying powers that have the same base. So 3, 3, 3. These are all going to be simplified. 2 with the 2. So what we're going to do is our 3 to the power of 2. So let me collect them. So we have 3 to the power of 2 times 3 to the power of 3, which is this and that. Then I'm left with times 2 to the power of 2 times 2 to the power of 6 over 3 to the power of 5. The rule states when you're multiplying powers that have the same base, keep the base and add the exponents. So we have 2 plus 3 is 5. So this part here simplifies to 3 to the power of 5. This part here, 2 to the power of 2 times 2 to the power of 6, simplifies to 2 to the power of 8. And then the bottom just stays as 3 to the power of 5. Now, whenever we have same powers, right, same base, 3 and 3, but we're dividing here, so when we're dividing, we are subtracting. So 3 to the power of 5 divided by 3 to the power of 5 actually divides out to 1. And then that